The T-800 has already proven that it can kick hard, move quickly, and survive some surprisingly rough demonstrations. But impressive movement inside a controlled environment is very different from sending a humanoid robot into the real world. Engine AI's latest update tackles one of the biggest problems standing in the way. The robot can now begin to feel the surface beneath its feet. Paxini's new tactile footwear adds direct contact sensing, while the T-800 walks across surfaces like grass, gravel, stone, and pavement. Meanwhile, Engine AI has opened a new production base in China and is preparing to build these robots at a much larger scale. Combine that with the T-800's powerful joints, reinforced structure, and high degree of mobility, and Engine AI is clearly trying to turn an impressive demonstration robot into something much more serious. Before we get into it, subscribe to Next Gen Humanoids for the biggest humanoid robot updates every week. So here's what actually dropped. Paxini fitted Engine AI's T-800 with special sensorized footwear built around multidimensional tactile sensing. In simple terms, the bottom of each foot can now feel what it is standing on. In the demo, the T-800 throws fast high kicks beside a punching bag, then walks across a smooth indoor floor, rough stone, grass, gravel, and broken pavement. Beside the footage, a live visualization shows pressure shifting under the soles as the robot moves. It fills an important gap in how humanoid robots understand the ground beneath them. Most humanoid robots already use cameras and LiDAR to study terrain before taking a step. Those systems can identify obstacles and help the robot decide where to place its feet. Sensors inside the joints also track how the legs and body are moving, but there is still a problem after the foot touches the ground. A camera can see that a surface looks uneven, but it cannot directly feel whether the heel landed first, whether only the toe is making contact, or whether the sole has started sliding sideways. Tactile sensing gives the robot information from the exact place where the foot meets the ground. Paxini's footwear is also designed to measure more than simple downward pressure. The sensing system can detect sideways force across the sole, which can be an early sign that a foot is beginning to slip. If the T-800 steps onto loose gravel, wet grass, or smooth flooring, the contact pattern changes. Grass compresses differently from stone, gravel can move under load, and smooth tile creates another type of force pattern. In theory, this could improve balance, terrain awareness, and future walking control. There is one important detail to keep clear. Paxini advertises very strong specifications for some of its commercial tactile sensors, including sensitivity down to 0.01 newtons, sampling rates around 1,000 readings per second, and IP68 protection against dust and water. However, those numbers describe Paxini's wider sensor family, not necessarily the exact footwear installed on this T-800. The demo also shows the pressure data being visualized on a screen, but it does not prove that the robot is already using all of that information to automatically adjust every step in real time. The footwear also appears to be modular and replaceable. Feet take repeated impacts every time the robot walks, runs, turns, or lands. If a sensing layer wears out, replacing a removable footwear module would be much easier than rebuilding an entire lower leg. That could make tactile systems easier to maintain in everyday use. And that becomes even more important when Engine AI is no longer thinking about just a handful of demonstration robots. On July 24, 2026, the first batch of Henan-made T-800 units rolled off Engine AI's new production base in Zhengzhou. The first stage of the site covers around 8,000 square meters and is planned for annual production capacity of about 5,000 robots. A later expansion is expected to push the site toward 10,000 robots per year, while total investment has been reported at close to 4.5 billion yuan. If a humanoid robot can now feel the ground beneath its feet, what sense do you think it needs next? Tell me below in the comments. Those numbers need context. A factory designed for 5,000 or 10,000 robots a year does not mean Engine AI is already producing at that level. Capacity is what the factory could potentially produce when the line, supply chain, workers, and demand are all operating at scale. Engine AI also did not reveal how many T-800 units were included in the first Zhengzhou batch, so the milestone confirms that production has started at the new site, but it does not yet show how quickly output is rising. Engine AI says every robot made there passes 79 quality checks and 46 simulated real-world tests before leaving the facility. The company also says automation improved production efficiency by 40% and that each robot receives a digital traceability file file that can track manufacturing and quality information tied to that specific unit. These remain company-reported claims and have not been independently audited. The bigger comparison comes from shipment numbers. According to research firm Omdia, Engine AI shipped roughly 400 robots during 2025. Across the Shenzhen and Zhengzhou sites, the company is now building toward annual capacity of around 15,000 robots. That creates a huge gap between past shipments and planned production capability. Closing it will require demand, reliable suppliers, and consistent quality control. The new factory shows that Engine AI is preparing for much larger volume, but the market still has to prove it can support that scale. And if Engine AI really wants to build the T800 in much larger numbers, the hardware underneath those new tactile feet becomes just as important as the sensing itself. The robot is built around 5 major physical characteristics that help explain how it can perform the aggressive movements shown in its demonstrations. First is peak joint torque of 450 Newton meters. Torque is the twisting force produced by a joint, or simply how strongly a motor can rotate a hip, knee, or another part of the body. The 450 Newton-meter figure should not be treated as the output of every joint. It represents the peak capability of the strongest joint setup. Large joints such as the hips and knees need much more force because they support and move most of the robot's weight. That peak torque helps the T800 perform deep squats, strong kicks, and recovery movements. Second is instant joint power of 14,000 watts, or 14 kilowatts. Power and torque are related, but they are not the same thing. Torque tells us how strongly a joint can turn, while power also includes how quickly that force is delivered. A robot can produce strong torque while moving slowly, but running, spinning, kicking, and stopping a limb quickly require both force and speed. Engine AI's 14 kilowatt figure refers to short-duration peak output, not continuous power use. That burst gives the T800 extra headroom for fast movements without throwing the body off balance. 14 kilowatts of instant joint power is a massive burst for a humanoid. What task do you think actually needs that much power outside a demo? Tell me in the comments. Third is the body construction. Engine AI uses aviation-grade aluminum alloy exterior panels combined with a high-strength alloy internal structure. Aluminum is useful because it offers a strong balance between weight and strength. A heavier body increases actuator load and energy use, while a weaker body could be more vulnerable during falls. The T800 stands about 1.73 meters tall and weighs around 75 kilograms, or roughly 165 pounds. That size creates serious impact loads when the robot falls or lands from dynamic movement, so a reinforced but relatively lightweight structure is important. Fourth is the impact-resistant structural design. Engine AI has built the T800 for aggressive movements, including combat-style demonstrations, kicks, spins, and situations where the robot may lose balance or take a hard hit. A stronger structure helps protect important joints and internal components when those forces travel through the body. Still, impact-resistant should not be confused with indestructible. Engine AI has not published a standardized drop test rating that would let us compare the T800 directly with industrial durability standards, so the claim should be treated as a design feature rather than proof that the robot can survive any fall. Fifth is its degrees of freedom. A degree of freedom is one independent direction in which a joint can move. More degrees of freedom give a humanoid robot more ways to coordinate the arms, legs, torso, and other body sections. Engine AI lists up to 29 degrees of freedom for the T800 Pro configuration, excluding the hands, while the base and developer versions are listed with 25. Those extra joints help with smoother whole-body movement, balance corrections, turning, and the coordination needed for more complex actions. Taken together, these updates show how quickly the T800 is moving beyond raw physical performance. Engine AI has already built a robot with powerful joints, a reinforced body, and the mobility needed for demanding movements. And if you want to know which humanoid robots are actually worth paying attention to, subscribe to Next Gen Humanoids for more breakdowns like this. Now Paxini's tactile footwear adds another layer by giving the robot direct information about the ground beneath its feet, while the new Zhengzhou production base could bring that technology to far more units. But the biggest questions are still ahead. Engine AI now has to prove that tactile sensing can improve real-world movement, that production can grow without sacrificing reliability, and that the T800 can perform consistently outside controlled demonstrations. Because building an impressive humanoid is one challenge, but making it useful, reliable, and scalable is a much bigger one.